This is section 4.2, day 2 on implicit differentiation. In exercises 9 through 12, find dy dx and find the slope of the curve at the indicated point. Let's do number 10. Let's find the derivative first. We have 2x as the derivative of x squared plus 2y dy dx is equal to 0. Now we have to get dy dx by itself. Let's minus over 2x. That's now equal to negative 2x, and then divide by 2y. We have dy dx is equal to negative x over y. The 2's will cancel out when we divide. We'll evaluate that at 0, 3. So dy dx, or the slope of the tangent line to the curve at 0, 3, is negative 0 over 3, which is 0. In exercises 13 through 16, find where the slope of the curve is defined. We're going to do number 15 straight out of the book. We have 3x squared plus 3y squared dy dx is equal to first times derivative of the second, and the derivative of the second is 1, but it's the derivative of y, so we have dy dx plus the second times the derivative of the first. Now let's minus over the x. We'll minus over the 3x squared. We have 3y squared dy dx minus x dy dx is equal to y minus 3x squared. Let's factor out the dy dx. We get 3y squared minus x, and that's equal to y minus 3x squared. And now we will divide. So we have dy dx is equal to y minus 3x squared over 3y squared minus x. And we want to find where the slope of the curve is defined. And the slope of the curve will be defined where x and y does not make the denominator 0. So slope is defined everywhere except when, well, we set this denominator equal to 0, and we find out that the denominator is equal to 0 when 3y squared equals x. So the slope is defined everywhere except when 3y squared is equal to x. When that happens, the denominator will be 0. In exercise 17 through 16, find the lines that are tangent and normal to the curve at the given point. On number 19, let's take the derivative. We have first times derivative of the second, which is 2y, and then the derivative of the inside function is dy dx, plus second times derivative of the first, and that's equal to the derivative of 9 is 0. Let's minus over the 2xy squared and divide by 2x squared y. We have dy dx is equal to negative x y squared over y x squared. And we can reduce this fraction. We can factor out an x or cancel out an x and cancel out a y. We have negative y over x. And we're going to evaluate that at negative 1, 3. Well, that's equal to, our x is negative 1, our y is 3, so we have negative 3 over negative 1, and that's a positive 3. So the tangent line is y minus 3 equals 3 times x plus 1, and the normal line is y minus 3 equals negative 1/3 times x plus 1. In exercises 27 through 30, use implicit differentiation to find dy dx and d2y over dx2. In other words, the second derivative. So let's take the first derivative. We have 2y dy dx plus 2 dy dx is equal to 2. Well, we can divide everybody by 2 and take out a dy dx. So we take out a dy dx, and we're left with y plus 1 when we divide everybody by 2, and that is equal to 1. dy dx, the first derivative, is equal to 1 over y plus 1. Now we can write that as, so dy dx is equal to y plus 1 to the negative 1. And that'll help us when we take the second derivative. Now we have d2y over dx2 is equal to negative y plus 1 to the negative 2, and then times dy dx. Well, we know what dy dx is, so we have negative 1 over y plus 1 squared. We'll take that negative power, send it to the denominator, make it positive, and that's going to be times the first derivative, which is 1 over y plus 1. So our second derivative is equal to negative 1 over y plus 1 to the third power.